Hey guys, Turk here. I hope you're having a great day. Rather than looking at any data, product reviews, or heck, even performance predictions, today we're going to be delivering you guys a public service announcement.
What you are about to see will be both graphic and disturbing. If you cringe at the sight of electronic suffering, please look away. Enthusiast discretion is advised.
Now, you guys know I love to game over on Twitch, and as I was doing an extended benchmarking session of Cyberpunk 2077, 4K, RTX on, all that good stuff, best way to play it, some of you guys came into chat and were asking me questions about my graphics card, and one of those that popped up to me was, Turk, have you noticed any RTX 3080 overheating problems on your game? So I love to answer you guys' questions while I stream. So we quickly paused the game and pulled up our latest version of Hardware Info 64. And sure enough, if you scroll down towards the bottom, you get access to the GPU sensors. And sure enough, our GPU temperature was right around 80 degrees Celsius, which is where my graphics card usually runs at. I've got a EVGA XC3 Ultra, link down below if you want more details on that. But what was alarming was the GPU memory junction temperature, and that was right at 94 degrees Celsius. Now again, I was running at 4K, all details at max or almost max settings, and to me, 94 degrees does seem kind of alarming, and I wanted to see if that was actually something of concern. So you guys were continuing to talk to me in chat, love it as always, and someone mentioned a video from Classical Technologies. I'll put a link up at the top right in case you want to check that out. But it looks like in his testing, he was doing extended GPU renders of like videos and whatnot, and he was able to get temperatures in excess of 104 degrees Celsius. Now, if y'all are familiar with thermal throttling, basically it's a device's mechanism of reducing its performance in order to keep its temperatures under control. And if you've got a CPU for AMD, it's usually around 80, 85 degrees Celsius where that kicks in. And with Intel, 100 degrees will start you getting thermal throttling. But now there's some questions as to what's an acceptable temperature for us to be running our GPUs at. And in his testing, Classical Technologies, he was seeing or guessing right around 110 degrees Celsius is where it begins to throttle. So I wanted to actually see if I could reproduce Classical Technologies testing. So what I did is I went ahead and closed out Cyberpunk, of course, and then I opened up my Blender benchmark run because that's the benchmark I have on this particular machine. I don't do a lot of like CPU or GPU rendering on my test bench, but I was able to load up the Blender benchmark, and I ran the entire benchmark, and I was getting memory temperatures, junction temperatures right around 94 degrees Celsius, which again kind of matches my gaming results, but it looked like he was getting prolonged GPU renders. So I went ahead and picked the longest GPU render for Blender, and I just ran that over and over and over again, like 6 or 8 times. And sure enough, I was able to get my memory junction temperatures to right around 96 degrees Celsius. So I'm clearly seeing a worst case condition when I'm doing extended GPU rendering. So I don't exactly match his results, but I'm seeing the same trends that he's seeing. So I wanted to do a little bit more investigation. Now, if you're not familiar with what memory is being used on the RTX 3080 and the 3090, they're using a quasi-proprietary memory called GDDR6X. Now, GDDR6X is a joint venture developed by Micron as well as NVIDIA, and it's actually not even ratified by the JEDEC Council. They're a governing body that helps standardize some of the memory standards, but you know, GDDR6, GDDR5X, those are some memory standards that JEDEC has control over. So it's really difficult to actually get the specific specifications for this particular type of memory, but lucky for us, Micron at least have some information out there. Let's actually pull that spec up real quick. And if you look up the part number, it's MT61K256M32JE-19, because that's the 19 gigabits memory module, same one that's in use, or similar one that's in use with the RTX 3080. Sure enough, if you look at the operational temperature, it actually specifies 0 to 95 degrees Celsius. Now, in my particular device, the EVGA XC3 Ultra, I am right at that upper limit of the temperature sections, but going to Classical Technologies, he's way above this spec. So I'm like, whoa, what do we look, what's the right value to look at here? So I did a little more research, and looking in the actual the data sheet for that particular module, we actually see another parameter called the T storage. And if we read the spec, stresses greater than those listed may cause permanent damage to my device. meep, 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 red flags going off. And sure enough, the storage temperature for this is between negative 55 to 125 degrees Celsius. So like, without having the actual spec in my hand for the memory devices that are in the RTX 3080, this is the best indicator I have of like the absolute minimum and maximum temperatures. And this, of course, these are stress temperatures. They're not, prolonged use cases. So 125 degrees C is the absolute maximum. But what about just like standard operational use? Well, fortunately for us, Micron also has a thermal applications document where they actually go and list the maximum junction temperatures that should be used while operating. Unfortunately, though, they don't have GDDR6X in that specification. They have GDDR5, 5X, and GDDR6. And sure enough, guys, 100 degrees Celsius is the maximum operating temperatures for those particular DRAMs. Of course, they are not GDDR6, so we can't make a direct comparison. But if you look at the rest of the memory on here, guys, unless we're using automotive-based DRAMs, we are getting above the spec just by running prolonged GPU rendering times. And that begs the question, guys, is an extended GPU render time a worst case scenario we could be putting our graphics card in, or is there some other application we could do that could push our graphics card to its limit in terms of the memory junction temperature? Well, if y'all are familiar with the current climate landscape, not like global warming or anything, but cryptocurrencies are becoming much more popular. Its value is just going through the roof. And sure enough, if your guys are mining Ethereum, that is putting a huge emphasis on the memory interface on your graphics card. And when I loaded it onto my RTX 3080, without any tuning, I was getting temperatures above 106 degrees Celsius. Now, when I was gaming, I was getting 94 degrees. When I was doing my extended GPU render, I was getting 96. And with mining Ethereum, again, not tuning my card at all, I was getting temperatures of 106 degrees Celsius. That is a 10 degrees above the extreme condition that I was hitting in normal uses. And if I was to apply that to classical technologies graphics card, I'm afraid he might even be getting into the 115s, the 116s, and getting close to that 125 degree maximum temperature. And sure, I can get my graphics card's memory to temperatures right around 90 degrees Celsius, maybe 88 or 86 if I open it up and put a huge fan in front of it. But that begs the question, if we run our graphics cards at these extreme temperatures between, 95 to 105, let's say, are we going to be running into any extended reliability concerns with our shiny new $1,000 graphics cards? Because, MSRPs don't mean anything these days. The short answer, probably. Now, I'm going to put a time code down here at the bottom. I've done a bunch of research on a bunch of different white papers that suggest some of the findings we'll be talking about. But in case you don't want to hear the mumbo jumbo, that time code's there. Go ahead and check out the rest of the video. But if you want to hear what actually is going to be happening to your GPU at these extreme conditions, keep on watching the video. Now, the first thing I wanted to look at was, does increasing the temperature of our GPU actually impact a memory's functionality over time? In the paper, An Extreme Study of Data Retention Behavior in Modern DRAM Devices, Carnegie Mellon researchers determined that extreme temperatures do have an impact towards a memory cell's retention time, which impacts how long a valid bit can be stored in a single cell. If you're not familiar with retention times, it's basically this window of time that a single bit of information can be stored in your memory. Now, as that retention time shrinks, that window of opportunity to get that memory back also shrinks. So as your GPU is trying to go and access memory, if that retention time is too short, your GPU is going to be finding invalid information in that cell, which in turn could be causing errors. For short amounts of stress, this really isn't an issue. But if you take temperatures between 25 degrees C and 125, we start to see elevated retention time degradation from runtimes between 4 months and 3 years of continual usage. And guys, at $1,000 a pop, an RTX 3080, I don't think it's really worth putting that kind of a component at risk to start throwing errors within 4 months of usage. That's a terrible thing to be investing my money into. Another paper about GPU errors on large-scale high-performance server clusters suggests that increases in temperatures do suggest increases in failure rates, though more research is required to validate this finding. What they mean here is these researchers, they actually looked at a national laboratories server farm that's doing weather simulations, all sorts of like Department of Defense stuff. And they found that as the server's temperature increased, the amount of failures that are being detected by the GPU also increased. Now, the thing that needs to be researched is what is actually failing. Is it the actual GPU die that's failing? Is it the interface between the memory and the GPU? Or is it in fact the DRAM that's causing the failures? Unfortunately, we're relying on software infrastructures, APIs from the different GPU vendors. But regardless, they're using similar types of GPUs, more work class grade, and if it's happening in those types of server farms running pretty good workloads, I don't see why it couldn't also apply to our local graphics card. However, a white paper from the University of Toronto covering the failure rates of a Google data center cluster, it finds that it wasn't temperature itself that correlated to failures, but the memory utilization. However, in this paper, they didn't take the test temperature to the extreme that we see, but this still is very concerning. And considering both our mining operations as well as long-term GPU renders use memory utilizations of 50 to 90%, this is not a very good scenario to be putting our graphics card in. And I think the information from this white paper is still relevant to our discussions here. Again, I'll put links to all these white papers down below in case you want some good reading material while you're waiting for your GPU renders to finish. So with temperature, if our memory cells start to degrade due to temperature and voltage changes, if the GPUs themselves start to throw errors at an increasing rate, and if our memory utilization starts to increase at a different rate, chances are, guys, that we are definitely putting our GPUs through some serious stress. And I've got a couple recommendations for you guys, and maybe take this into account before you go and buy a graphics card. So what does this mean for casual gamers? Now, as long as you're running your graphics card between 3 hours and 6 hours, chances are you're not really putting your graphics card at risk here. Again, going back to my Cyberpunk 2070 tests we did earlier, I was getting around 94 degrees Celsius on my particular graphics card. It's in a pretty decent case, so I wouldn't expect my graphics card to be at risk here, but if y'all are in many ITX enclosures, if you have poor airflow, or if y'all have gotten some of the budget coolers based on your graphics card, you might want to invest in better cooling, but chances are you're probably not at risk for failure in the short term if you're a casual gamer. But how about prosumers that undergo these extended GPU render times that classical technology was referencing? Again, this goes back to proper airflow, proper case selection, and graphics card selection in order to reduce the chance of failure in your system. Now, if you happen to have got the wrong card or your GPU is throwing up some pretty extensive temperatures, this might be a great opportunity to invest in a water cooling block from the likes of EK. I've actually got an EK water block on my GTX 1080 here, and running Ethereum mining while on my little custom loop here, my GPU's just humming along right at 47 degrees Celsius. So maybe this is an opportunity to start investing in a better cooling solution for your prosumer rig. And for all you GPU miners out there, first thing, you guys really suck. But to help you guys out, I'm suggesting picking alternative cards for better use. Now, sure, RTX 3080s and 3090s throw up some massive hash rates when it comes to all the different algorithms out there. But when it comes to hashing per watt, there's definitely some good alternatives out there that don't cost as much. I'm actually running my RX 5600 XT, again, mining Ethereum over in my little server room. And unfortunately, it doesn't get as good of hash rates, but if you compare it to its efficiency, it's almost double that of an RTX 3080 with proper tuning applied. And now GTX 1080s, like the one I've got in my render rig, sure, they're not as powerful as an RTX 3080 and they're not as efficient, but guys, they're about 1/5 the cost of an RTX 3080 over on eBay. So if you're wanting to push and hammer these things to the point where they break, it might be best to invest in a graphics card that's you can actually replace and get a fresh stock at relatively low cost. And my last word of warning for any of y'all that are looking for graphics cards on the used market, I would definitely tread lightly here. Unless you know the seller or you can actually visually inspect the graphics card, I would put a lot of grains of salt into picking a card that looks like it's too good to be true, especially if it's like on eBay or Craigslist. And those are all the warnings I've got for you guys. If you're going to be getting a graphics card for these types of applications, definitely invest in proper cooling, definitely invest in proper graphics cards, and don't risk these fancy graphics cards that, a lot of actual gamers want to buy and use for gaming. So let's share this information out there. Make sure you guys are well aware of the risks involved with any of these types of activities. But thank you guys for watching the video. Hit the subscribe button down below if you liked what you saw. I've got some more tech reviews coming down the way, and I've actually been interfacing with a pretty prominent manufacturer, and I've got some good news to share with y'all. So make sure y'all hit the bell icon so y'all know when that video drops. But again, guys, thank you for watching the video. Hope you have a great day. Take care.